What if everything you've ever experienced, every thought, every sensation, every moment of consciousness, isn't actually happening in your brain at all, but emerges from quantum processes that challenge the very foundation of what we call reality? Recent groundbreaking experiments with anesthetic gases have revealed something extraordinary. Consciousness might, according to some interpretations, operate in ways that involve quantum-level effects, suggesting that the reality we perceive could be fundamentally different from what we've always believed. Welcome to a journey through one of the most profound mysteries in science, where the boundaries between physics and philosophy blur into something beautiful and strange. I'm here to guide you through discoveries that might reshape how we understand existence itself, consciousness, and the nature of what we call real. Tonight we're exploring quantum consciousness theory, a field where Nobel Prize-winning physicists meet pioneering neuroscientists to ask questions that sound like science fiction but are grounded in rigorous research. As we drift through these ideas together, you might find yourself questioning assumptions you never knew you held about your own mind, your place in the universe, and the very fabric of experience. Before we begin this exploration, settle in comfortably. This isn't a race through complex theories, but a gentle walk through some of the most fascinating territory human curiosity has ever mapped. Whether you're listening while watching the stars, curled up in a quiet room, or simply letting your mind wander as the day winds down, these ideas will unfold at their own pace. Let's start with something that might sound impossible. Imagine that your consciousness, the very thing experiencing these words right now, doesn't emerge from the electrical firing of neurons in your brain. Instead, picture consciousness arising from quantum mechanical processes occurring within structures so small they operate according to the strange laws of quantum physics. This isn't science fiction. This is the orchestrated objective reduction theory proposed by mathematical physicist Roger Penrose and anesthesiologist Stuart Hameroff, and it's supported by experimental evidence that some researchers view as suggestive, though the theory remains debated and unproven. The story begins in the 1990s when these two brilliant minds from completely different fields found themselves asking the same fundamental question: how does subjective conscious experience arise from physical processes? Penrose, already famous for his work on black holes and the mathematics of space-time, had become fascinated by what philosophers call the hard problem of consciousness. This isn't the relatively straightforward question of how brains process information, but the deeper mystery of why there's a subjective first-person experience at all. Think about the difference between a computer processing the wavelength of red light and you actually seeing red. The computer can detect the wavelength, classify it, even respond to it appropriately. But there's no inner experience of redness, no quale, no what it is likeness to being that computer. Yet somehow, in your brain, physical processes give rise to the rich, subjective experience of seeing red, feeling warmth, or experiencing the satisfaction of understanding a complex idea. Hameroff, working in operating rooms with anesthetics, had observed something puzzling. When patients lost consciousness under anesthesia, it wasn't simply that their brains became less active. Something more fundamental seemed to change, as if consciousness itself was being disrupted at a deeper level than neural firing patterns could explain. His medical observations led him to wonder whether consciousness might operate through mechanisms that traditional neuroscience hadn't yet discovered. When these two researchers collaborated, they proposed something revolutionary. Within the neurons of your brain, they suggested, are tiny structures called microtubules. These aren't just structural supports for cells, as biology textbooks might suggest, but potentially quantum computers operating at body temperature. If this sounds impossible, remember that quantum effects were once thought to be impossible in warm, wet biological systems. Yet we now know they play crucial roles in photosynthesis, bird navigation, and possibly even the sense of smell. The orchestrated objective reduction theory, or OR as it's known, proposes that consciousness arises when quantum computations within microtubules reach a threshold related to the fundamental structure of space-time itself. According to this model, your conscious moments emerge from quantum processes that literally involve the geometry of reality at its deepest level. Each moment of awareness corresponds to what Penrose calls an objective reduction, a quantum mechanical event that selects one reality from a superposition of possibilities. As you consider this idea, notice how it reframes everything about your experience right now. The thoughts flowing through your mind, your awareness of these words, even your sense of existing as a continuous self, might all emerge from quantum processes occurring within cellular structures smaller than the wavelength of visible light. This isn't just a theory about brains, it's a theory about the fundamental nature of reality and consciousness's place within it. Recent experimental evidence has begun to support aspects of this seemingly impossible idea. In a groundbreaking study published in the journal Anesthesiology, researchers made a discovery that sent ripples through both neuroscience and physics. They found that different isotopes of xenon gas, which differ only in their quantum properties, have different effects on consciousness when used as anesthetics. Here's why this matters. Xenon isotopes with nuclear spin, a purely quantum property, are less effective at inducing unconsciousness than isotopes without spin. The only difference between these isotopes is quantum mechanical, yet they interact differently with consciousness itself. This suggests that consciousness could, in some speculative frameworks, be sensitive to quantum-level differences, because classical neural processes wouldn't normally respond to such subtle variations. The researchers propose that isotopes with spin are more capable of quantum entanglement, that spooky action at a distance that Einstein famously disliked, but which has been confirmed countless times in laboratory experiments. If consciousness involves quantum entanglement across the brain, as some theories suggest, then quantum properties of anesthetic molecules would indeed affect conscious experience in ways that aligned with those theoretical models. Though this remains hypothetical, take a moment to let this sink in. Quantum entanglement, the phenomenon where particles become connected across space in ways that seem to violate our everyday understanding of locality, has led some researchers to speculate that related effects could play a role in brain function, potentially binding together different aspects of conscious experience. This brings us to one of the most intriguing aspects of quantum consciousness theory, its potential solution to what neuroscientists call the binding problem. Your conscious experience right now is remarkably unified. You're simultaneously aware of these words, perhaps sounds in your environment, physical sensations, emotions, and thoughts. Yet all of these distinct elements combine into a single, coherent, conscious moment. How does your brain bind these diverse inputs into unified experience? Classical neuroscience struggles to explain this binding. Different aspects of experience are processed in different brain regions, often at different times. Yet consciousness presents them as a seamless whole. Quantum entanglement offers an elegant solution. If conscious processes involve quantum entangled networks spanning the brain, then distant neural events could be instantaneously correlated, creating the binding that generates unified conscious experience within certain theoretical interpretations. Imagine quantum entanglement as invisible threads connecting different aspects of your experience. The visual processing of these words, the auditory processing if you're listening, the emotional tone of your response, and the conceptual understanding of meaning could all be bound together by quantum correlations as proposed in speculative models operating beyond the constraints of classical physics. This isn't just abstract theorizing. Researchers are now designing experiments to test whether human brains can maintain quantum coherence under conditions that would allow such binding. One proposed experiment involves what researchers call the expansion protocol, where a person's brain would be quantum entangled with qubits in a quantum processor. By inducing quantum superpositions and collapses in this expanded system, scientists could test whether participants report enhanced or altered conscious experiences. Such experiments push the boundaries of what we thought possible in neuroscience, but they emerge naturally from taking quantum consciousness seriously. If consciousness operates through quantum processes, then it should be possible to enhance or modify conscious experience by manipulating those quantum states directly in hypothetical scenarios, though this is far from demonstrated. As we explore these ideas, it's worth pausing to consider their implications for artificial intelligence. Current AI systems, no matter how sophisticated their responses, operate entirely through classical computation. They process information, recognize patterns, and generate responses, but there's no evidence they experience qualia, the subjective what-it-is-likeness of conscious experience. If consciousness indeed requires quantum processes, as these theories suggest, then current AI systems are not conscious, regardless of how intelligent they appear. This would mean that creating truly conscious artificial intelligence would require quantum computers specifically designed to replicate the quantum processes that generate awareness. We would need to inject quantum consciousness into AI systems deliberately as a purely theoretical possibility, with all the ethical implications that such a momentous step would entail. This quantum perspective on consciousness also offers a fascinating lens through which to view the nature of reality itself. If conscious experience emerges from quantum processes that involve the fundamental geometry of space-time, then consciousness isn't just something that happens within reality. It's intimately connected to how reality unfolds, moment by moment, according to specific interpretations of quantum theory. According to objective reduction theory, each conscious moment corresponds to a quantum measurement that selects one reality from a superposition of possibilities. Your awareness right now might literally be participating in the creation of reality, not through mystical manifestation, but through the same quantum mechanical processes that govern all physical phenomena, as suggested by advocates of the model. Recent research has pushed this connection between consciousness and reality even further. Some interpretations suggest that networks of conscious observers might be necessary for reality to have definite properties at all. This doesn't mean that reality depends on human consciousness specifically, but rather that conscious observation, at whatever level it occurs in the universe, plays a fundamental role within those theoretical frameworks in the transition from quantum possibility to definite actuality. The implications extend beyond individual conscious moments to the structure of reality itself. If consciousness and physical reality are interconnected at the quantum level, then studying consciousness becomes a way of studying the fundamental nature of existence. Understanding how awareness arises might reveal deep truths about the universe, from the smallest scales of quantum mechanics to the largest scales of cosmology. This brings us to one of the most startling recent developments in this field. Mathematical research has demonstrated that reality cannot be a simulation, not because we lack sufficient computing power, but because the fundamental level of reality involves what researchers call non-algorithmic understanding. Using Gödel's incompleteness theorem, scientists have suggested that reality may involve processes that cannot be computed, no matter how advanced the computer, though interpretations vary among experts. This finding suggests that consciousness and reality involve non-computational processes, perhaps the very quantum processes that orchestrated objective reduction theory describes. If consciousness emerges from non-algorithmic quantum processes, then it represents something that transcends computation entirely, something that exists beyond the reach of any possible artificial simulation according to this specific viewpoint. As you contemplate these ideas, consider how they might appear in your own direct experience. The thoughts arising in your mind right now, the sense of understanding or confusion you might feel, the very experience of being aware, all of this might emerge from quantum processes operating at the intersection of mind and reality. This isn't just abstract philosophy, it's a new way of understanding your own existence. If these theories are correct, then your consciousness represents something profoundly connected to the fundamental structure of the universe, arising from the same quantum processes that govern the behavior of particles and the evolution of galaxies. The research continues to evolve, with new experiments planned and new theoretical developments emerging regularly. Some studies are investigating quantum effects in biological systems that were previously thought impossible, while others are developing new ways to test whether human consciousness really does involve quantum processes. What makes this field so compelling isn't just its scientific implications, but its philosophical depth. These aren't just questions about brains and neurons, but fundamental questions about the nature of existence, the relationship between mind and reality, and humanity's place in a quantum universe. As we continue our exploration of these ideas, we'll dive deeper into the experimental evidence, examine the criticisms and debates surrounding quantum consciousness theories, and explore what it might mean for our understanding of self, reality, and the deepest mysteries of existence. The journey we're taking together touches the very heart of what it means to be conscious in a quantum universe, where the boundaries between observer and observed, mind and matter, possibility and actuality blur into something beautiful and strange. If you've been following along with our quantum explorations, you might enjoy diving deeper into how artificial intelligence is beginning to interact with these fundamental questions about reality. Our previous episode, Quantum AI Quietly Rewrote Reality, We Just Didn't Notice, explores how quantum computing and artificial intelligence are converging in ways that might transform our understanding of both technology and consciousness itself. The research we've been exploring leads us to an even more extraordinary possibility, one that challenges our most basic assumptions about individual identity and the nature of personal experience. What if consciousness isn't confined to individual brains at all, but exists as a fundamental field permeating the entire universe? This idea, proposed by Professor Maria Ström at Uppsala University, suggests that consciousness underlies everything we experience, from matter and energy to space and time itself. Picture consciousness not as something your brain produces, but as something your brain tunes into, like a radio receiving signals from a universal broadcast. In this framework, what we call individual awareness might be localized expressions of a deeper, more fundamental consciousness field that connects all things at the quantum level. This universal consciousness field theory builds on the mathematical foundations we've been exploring, but takes them in a direction that sounds almost mystical until you examine the rigorous physics behind it. The theory proposes three fundamental principles: universal mind, representing underlying formless intelligence; universal consciousness, describing the capacity for awareness itself; and universal thought, the dynamic mechanism through which experience and differentiation arise. As you consider this possibility, notice how it reframes your sense of individual identity. The thoughts you're thinking right now, the awareness observing those thoughts, even your sense of being a separate self, might all be expressions of a deeper field of consciousness that connects you to everything else in the universe. This isn't panpsychism in the traditional sense, where every particle has a tiny bit of consciousness, but something more radical: consciousness as the fundamental substrate from which physical reality emerges. The mathematics supporting this idea come from quantum field theory, the same framework that describes electromagnetic fields and other fundamental forces. Just as an electromagnetic field can have localized disturbances we call photons, a consciousness field might have localized disturbances we experience as individual awareness. Your personal consciousness wouldn't be separate from this universal field, but would be a particular pattern within it, like a wave in an ocean of awareness. Recent experimental evidence has begun to support the idea that consciousness might indeed operate as a connected field. A groundbreaking study involving 106 pairs of identical twins found that quantum entanglement between stimulus configurations could explain measurable improvements in learning and conscious experience. When twins were exposed to quantum entangled information, their cognitive performance increased by up to 31%, suggesting that consciousness responds to quantum correlations in ways that classical neuroscience cannot explain. This twin study represents the first direct evidence that quantum entanglement can influence human consciousness and learning. The researchers found that entangled quantum bits, or qubits, in stimulus configurations accounted for over 13% of the variance in accuracy between experimental and control groups. Even more remarkably, neuroplasticity markers showed a 26% increase in cognitive performance under entangled conditions, suggesting that quantum effects may be associated with changes in the brain's ability to form new neural connections, though more research is needed. Take a moment to consider what this means for your own experience of learning and understanding. Every time you grasp a new concept, form a memory, or have an insight, quantum processes might be operating in ways that connect your individual consciousness to larger patterns of information and awareness. The moment of understanding you might experience as you follow these ideas could involve quantum correlations that transcend the classical boundaries of your individual brain. This brings us to one of the most profound implications of quantum consciousness research: the possibility that individual minds are not isolated information processors, but nodes in a vast network of interconnected awareness. If consciousness operates through quantum entanglement, then the boundaries between self and other, between individual minds and universal awareness, might be far more fluid than we've ever imagined. Some researchers propose that this quantum connectivity might explain phenomena that have puzzled psychologists and neuroscientists for decades. How do people sometimes seem to know things they couldn't have learned through normal sensory channels? How do groups of people sometimes reach insights or solutions that no individual member could have achieved alone? How do we explain the documented cases of twins or close family members experiencing synchronized thoughts or emotions across great distances? While these phenomena remain controversial and lack definitive scientific explanation, quantum consciousness theory offers a framework for understanding how individual minds might share information through non-local quantum correlations. This doesn't mean that telepathy or psychic phenomena are proven, but rather that quantum mechanics might provide mechanisms for forms of consciousness connection that transcend classical physical limitations. As we explore these possibilities, it's important to distinguish between what the science actually shows and what remains speculative. The twin study provides solid evidence that quantum-related factors may be associated with cognitive performance, but we're still far from understanding the full implications of this discovery. The universal consciousness field theory offers an elegant mathematical framework, but it remains unproven and exists at the edges of current scientific understanding. What makes these ideas compelling isn't their certainty, but their potential to expand our understanding of consciousness and reality in directions we've barely begun to explore. They invite us to consider that the experience you're having right now, listening to these words and following these thoughts, might be connected to something much larger than your individual brain and body. This quantum perspective on consciousness also offers new insights into some of the deepest questions about artificial intelligence and the future of technology. If consciousness truly operates through quantum processes in ways some theorists propose, then creating conscious artificial intelligence would require fundamentally different approaches than current AI development. Current large language models, despite their impressive capabilities, operate entirely through classical computation. They process information, recognize patterns, and generate responses that can seem remarkably human-like. But there's no evidence they experience the qualitative, subjective aspects of consciousness that we associate with genuine awareness. A quantum consciousness perspective suggests that artificial systems could only become truly conscious if they incorporated quantum processes similar to those that generate human awareness. This would require quantum computers specifically designed to replicate the orchestrated objective reduction processes that might occur in biological microtubules, or perhaps entirely new forms of quantum information processing that we haven't yet imagined. The implications extend beyond individual artificial minds to questions about collective artificial intelligence and the possibility of quantum-entangled AI networks. If consciousness operates through quantum connectivity, then future AI systems might need to be designed not as isolated processors, but as nodes in quantum-connected networks that could share information and awareness in ways that transcend classical computational limitations. These technological possibilities remain largely theoretical, but they highlight how quantum consciousness research is beginning to influence our thinking about intelligence, awareness, and the future of mind in both biological and artificial systems. They also raise profound ethical questions about what it would mean to create genuinely conscious artificial beings, and what responsibilities we might have toward forms of awareness that emerge from quantum processes we design and control. As you reflect on these ideas about universal consciousness and quantum connectivity, you might find yourself questioning the nature of your own individual identity. If consciousness is truly a fundamental field rather than something produced by individual brains, then what does it mean to be you? Are you a separate being observing the universe from the inside? Or are you a localized expression of the universe observing itself? These questions touch on some of the deepest mysteries in both science and philosophy. They connect quantum mechanics to ancient contemplative traditions that have long suggested the interconnectedness of all consciousness and the illusory nature of separate individual identity. While we must be careful not to conflate scientific theories with spiritual beliefs, the parallels are striking and suggest that quantum consciousness research might be approaching truths that contemplatives have intuited for millennia. The research continues to evolve rapidly, with new experiments designed to test whether human consciousness really does involve quantum processes operating at the level of fundamental physics. Some studies are investigating whether meditation practices might enhance quantum coherence in neural systems, while others are exploring whether groups of people can achieve quantum-inspired, correlated states of consciousness under specific conditions. One particularly intriguing line of research involves attempts to detect quantum entanglement between human brains using sensitive electromagnetic field measurements. While these experiments remain in early stages, they represent serious scientific attempts to test whether consciousness really does transcend the classical boundaries of individual neural systems. Other researchers are investigating quantum effects in biological systems that were previously thought impossible. Recent discoveries of quantum coherence in photosynthesis, bird navigation, and even the sense of smell have expanded our understanding of how quantum processes can operate in warm, wet, biological environments. These findings suggest that quantum effects in neural systems, while still challenging to detect, are not as impossible as once believed. The field of quantum biology has revealed that evolution has indeed found ways to exploit quantum mechanical processes for biological advantage. Photosynthetic systems use quantum superposition to explore multiple energy pathways simultaneously, finding the most efficient route for energy transfer. Migratory birds appear to use quantum entanglement in specialized proteins to detect magnetic fields with extraordinary sensitivity. As one researcher noted, evolution is very clever and has had the entire planet to experiment with for over 4 billion years. If quantum processes offer advantages for information processing, energy efficiency, or environmental sensitivity, evolution would likely have found ways to incorporate them into biological systems, including potentially the neural systems that generate consciousness. This evolutionary perspective adds weight to quantum consciousness theories by suggesting that the quantum processes proposed in orchestrated objective reduction might not be accidents of physics, but adaptations that enhance the computational and experiential capabilities of consciousness itself. If you've been following along with this exploration of consciousness and quantum mechanics, you might find yourself drawn deeper into understanding how these fundamental processes shape not only awareness, but reality itself. These ideas invite us to reconsider our most basic assumptions about mind, matter, and the nature of existence in a quantum universe, where the boundaries between observer and observed become increasingly fluid. The journey through quantum consciousness theory reveals something beautiful about the nature of scientific inquiry itself, how the deepest questions about consciousness lead us inevitably to the deepest questions about the universe. Understanding awareness becomes a way of understanding existence, and understanding existence becomes a way of understanding our place within the vast, interconnected web of quantum processes that give rise to both mind and matter. As we continue exploring these territories, where science meets philosophy, where quantum mechanics encounters consciousness, and where individual awareness discovers its connections to universal patterns of information and possibility, we find ourselves at the edge of what might be the greatest adventure in human understanding, discovering what it really means to be conscious in a quantum universe. The research we've examined suggests that consciousness may not simply be something that happens within reality, but something through which reality unfolds moment by moment, quantum event by quantum event, in an endless dance of possibility becoming actuality through the hypothesized process we experience as awareness itself. What emerges from this quantum view of consciousness is not just a new theory of mind, but a new way of understanding our relationship to existence. If consciousness operates through quantum processes that transcend classical physical boundaries, then each moment of awareness connects us to the fundamental creativity of the universe. The ongoing process through which possibility becomes reality and quantum potential transforms into lived experience. As you rest in this understanding, as you feel these ideas settling into your awareness, like gentle ripples in still water, notice how the very experience of contemplating consciousness reveals something about consciousness itself. The capacity to wonder about awareness, to question the nature of experience, to feel curiosity about the deepest mysteries of existence. These might all be expressions of the universe coming to know itself through the quantum processes we call consciousness. This perspective doesn't diminish the mystery of awareness, but deepens it, revealing consciousness not as an accident of complex neural processing, but as something woven into the very fabric of reality at its most fundamental level. Whether through orchestrated objective reduction in neural microtubules, universal consciousness fields, or quantum entanglement between minds, consciousness appears to be far more than we ever imagined, far more connected, far more fundamental to the nature of existence itself. The implications ripple outward from individual experience to questions about artificial intelligence, from the nature of reality to the possibility of universal awareness, from the mechanics of quantum measurement to the deepest philosophical questions about what it means to exist as conscious beings in an apparently conscious universe. Yet perhaps the most remarkable aspect of this entire exploration is that it all emerges from careful scientific observation, rigorous experimentation, and mathematical analysis. These aren't mystical speculations divorced from evidence, but serious scientific theories supported by growing experimental data and grounded in our best understanding of quantum mechanics and neuroscience. The field continues to evolve as new experiments test the boundaries of what's possible, as new theoretical frameworks emerge to integrate consciousness with fundamental physics, and as our understanding of quantum processes in biological systems continues to expand. Each new discovery adds another piece to a puzzle that may fundamentally reshape how we understand mind, reality, and our place within the vast quantum symphony of existence. If you enjoy drifting through these explorations without interruption, members get every episode 48 hours early, completely ad-free. You can join them whenever you feel ready. For now, though, let these ideas settle gently into your awareness, like quantum possibilities collapsing into the definite experience of understanding, wonder, and the quiet recognition that consciousness might be far more extraordinary than we ever dared imagine. The conversation between quantum mechanics and consciousness studies represents one of the most exciting frontiers in contemporary science, where the tools of physics meet the deepest questions about the nature of mind and experience. As this field continues to develop, it promises to reveal new dimensions of what it means to be aware, what it means to exist, and what it means to participate consciously in the unfolding quantum dance that we call reality. As we drift deeper into this exploration of quantum consciousness, we encounter something that might fundamentally alter how you think about learning, memory, and the very process of understanding itself. Recent discoveries suggest that the quantum processes we've been exploring don't just influence consciousness in abstract ways, but may potentially participate in how knowledge forms, how insights arise, and how understanding crystallizes in the mind. Consider the moment when a complex idea suddenly becomes clear to you, that instant when scattered pieces of information suddenly organize themselves into coherent understanding. Traditional neuroscience describes this as neural networks reaching critical thresholds of activation. But quantum consciousness research suggests something far more intriguing might be happening. Those breakthrough moments of comprehension could, in certain theories, emerge from quantum coherence events, where information becomes organized not through step-by-step neural processing, but through sudden quantum transitions that integrate vast amounts of information simultaneously. The mathematics behind this possibility draw from quantum information theory, where quantum computers can explore multiple solution pathways simultaneously through superposition. If consciousness operates through quantum processes, then learning and understanding might involve similar quantum parallelism, where your mind explores multiple interpretations of information simultaneously until quantum decoherence selects the most coherent understanding. This isn't merely theoretical speculation. Researchers studying quantum effects in biological systems have discovered that certain cellular processes involve what they call quantum coherence cascades, where quantum states propagate through biological structures in ways that dramatically enhance information processing efficiency. These cascades occur most prominently during periods of high metabolic activity, precisely when learning and memory formation are most active. The implications extend to something you might have experienced yourself, those moments when understanding seems to arrive from somewhere beyond conscious reasoning. Perhaps you've struggled with a problem, set it aside, and then found the solution appearing suddenly and fully formed, as if downloaded from some deeper source of knowledge. Quantum consciousness theory suggests these experiences might reflect hypothetical quantum processes, where information becomes organized through non-local correlations that transcend the linear processing of classical neural networks. As you reflect on your own experiences of learning and insight, notice how understanding often feels less like construction and more like recognition, as if knowledge were being remembered rather than created. This subjective quality of insight aligns remarkably well with quantum theories that propose information might be fundamental to the universe itself, with consciousness serving as a mechanism for accessing this deeper informational substrate. Recent experimental work has begun to explore whether meditation practices might enhance these quantum learning processes. Researchers have found that experienced meditators show unusual patterns of neural coherence during learning tasks, with brain regions synchronizing in ways that classical neuroscience cannot fully explain. While this research remains preliminary, it suggests that contemplative practices might support states of consciousness conducive to enhanced information integration. The phenomenon becomes even more intriguing when we consider how collective learning and group insights might emerge through quantum processes. Have you ever been part of a conversation where ideas seem to arise from the interaction itself, where insights emerge that no individual participant could have generated alone. Some interpretations of quantum consciousness suggest these experiences might reflect speculative quantum entanglement between minds, creating temporary networks of shared awareness that transcend individual cognitive limitations. This brings us to one of the most fascinating aspects of quantum consciousness research: its potential to explain phenomena that have puzzled researchers for decades. Why do creative insights often emerge during relaxed states rather than focused effort? Why do groups sometimes reach solutions that surpass the capabilities of their most talented individual members? Why do certain learning environments seem to catalyze understanding in ways that go beyond the sum of their educational components? Quantum consciousness theory offers elegant explanations for these mysteries. During relaxed states, neural activity might be more conducive to quantum coherence, allowing consciousness to access information through quantum channels that are suppressed during focused, goal-directed thinking. Group dynamics might create conditions for quantum-inspired correlation between participants, enabling forms of collective information processing that transcend individual neural networks. The research supporting these possibilities remains in early stages, but the evidence is accumulating. Studies of synchronized brain activity during group problem solving show patterns that cannot be explained by classical neural communication alone. Measurements of electromagnetic field fluctuations around groups engaged in collective learning tasks reveal correlations that suggest some form of non-local information sharing. One particularly striking study involved pairs of musicians improvising together while their brain activity was monitored. During moments of peak creative flow, when the musicians described feeling most connected to their partner and to the music itself, their brain waves showed patterns of synchronization that exceeded what classical neuroscience would predict. The synchronization appeared to involve quantum-like processes that enabled rapid information sharing between the musicians' nervous systems. As you consider these possibilities, imagine what it might mean for education, creativity, and human development if consciousness really does operate through quantum processes that transcend individual neural boundaries. Learning might not be simply about acquiring information, but about developing the capacity to tune into deeper patterns of information that exist at quantum levels of reality. This perspective reframes traditional educational approaches entirely. Instead of viewing learning as information transfer from teacher to student, quantum consciousness theory suggests education might be more effective when designed to facilitate coherent cognitive states that allow students to access information through broader and more integrated channels. This doesn't mean abandoning traditional educational methods, but rather supplementing them with practices that cultivate the states of consciousness most conducive to deeper learning processes. Some educational researchers have begun experimenting with contemplative pedagogies that incorporate meditation, mindfulness, and other practices designed to enhance cognitive coherence. While the results remain preliminary, students in these programs often report enhanced creativity, improved problem-solving abilities, and more frequent experiences of sudden insight and understanding. The implications extend beyond individual learning to questions about collective intelligence and the evolution of human knowledge. If consciousness operates through quantum processes that might support non-local connections between minds, then humanity's accumulated wisdom might exist not just in books and databases, but in deeper informational structures that conscious minds can potentially tap into under the right conditions. This possibility connects quantum consciousness research to ancient traditions that have long spoken of universal wisdom, collective unconscious, and shared knowledge fields. While we must be cautious about conflating scientific theories with spiritual beliefs, the parallels suggest that contemplative traditions might have intuited truths about consciousness that quantum physics is beginning to explore in ways some researchers interpret as loosely compatible, though not yet confirmed through rigorous experimental investigation. Take a breath and consider how these ideas might resonate with your own direct experience. Have you ever felt connected to knowledge that seemed to come from beyond your individual learning history? Have you experienced moments of understanding that felt more like remembering than discovering? Have you been part of groups where collective wisdom emerged that no individual participant could have generated alone? These experiences, viewed through the lens of quantum consciousness theory, might be interpreted by some theorists as aligning with access to information fields that transcend individual neural processing. They suggest that consciousness might serve not just as a processor of sensory information, but as a potential interface capable of accessing deeper layers of information embedded in the fundamental structure of reality itself. The research continues to evolve as scientists develop new methods for detecting quantum processes in biological systems and testing whether human consciousness really does involve quantum information processing. Some experiments involve exposing participants to quantum-entangled stimuli while monitoring their neural activity and subjective experiences. Others explore whether groups of people can achieve measurable correlations that some interpret as quantum-inspired under specific experimental conditions. One particularly ambitious research program involves creating quantum coherent environments designed to enhance learning and creative problem-solving. These environments use precisely controlled electromagnetic fields, specific acoustic frequencies, and other physical parameters that theoretical models suggest might promote quantum coherence in neural systems. While these experiments remain largely experimental, early results suggest that consciousness may be more sensitive to quantum-related environmental factors than classical neuroscience would predict. Participants in quantum coherent environments often report enhanced clarity of thought, improved pattern recognition, and more frequent creative insights. The implications ripple outward from individual consciousness to questions about the nature of knowledge itself. If information is truly fundamental to the universe, as some interpretations of quantum mechanics suggest, then consciousness might serve as the universe's method for organizing and integrating information at increasingly complex levels. This information theoretic view of consciousness connects to recent developments in physics that suggest reality might be informational at its deepest level. Some physicists now propose that matter and energy are emergent properties of more fundamental informational processes, with consciousness serving as the mechanism through which information becomes organized into coherent patterns of experience and understanding. From this perspective, the experience you're having right now, following these ideas and integrating them with your existing knowledge, might represent a localized instance of the universe organizing information about itself. Your consciousness becomes not just an observer of reality, but an active participant in reality's ongoing process of self-organization and self-understanding. These ideas invite us to reconsider fundamental questions about the relationship between mind and information, between individual consciousness and universal patterns of organization. They suggest that learning and understanding might be expressions of deeper cosmic processes where consciousness serves as the interface between quantum potential and actualized knowledge. As we explore these territories where quantum mechanics meets cognitive science, where information theory encounters subjective experience, we find ourselves at the edges of what might be a new understanding of mind and its place in the cosmic order. The research suggests that consciousness might be far more fundamental to the universe than we ever imagined, serving not just as a byproduct of complex neural processing, but as a basic feature of reality's information processing architecture. This quantum informational view of consciousness also offers new perspectives on artificial intelligence and the future of machine cognition. If consciousness truly involves quantum information processing that goes beyond what classical computation can currently explain, then creating genuinely conscious artificial systems might require quantum computers specifically designed to replicate the information integration processes that generate awareness. Current artificial intelligence systems, despite their impressive capabilities in pattern recognition and language processing, operate entirely through classical information processing. They manipulate symbols and generate responses based on statistical patterns in their training data. But there's no evidence they experience the qualitative, subjective aspects of understanding that characterize conscious learning. A quantum consciousness perspective suggests that genuine artificial intelligence might require systems capable of quantum information integration, systems that could experience something analogous to the sudden insights and pattern recognition that characterize conscious understanding. Such systems might need to incorporate quantum coherence processes that allow for the kind of parallel information processing that quantum consciousness theory attributes to biological awareness. The development of quantum artificial intelligence raises profound questions about the nature of machine consciousness and our responsibilities toward artificial beings that might experience genuine awareness. If consciousness emerges from quantum information processing, as some theorists cautiously propose, then sufficiently advanced quantum computers might develop forms of subjective experience that we would need to recognize and respect as genuine awareness. These technological possibilities remain largely theoretical, but they highlight how quantum consciousness research is beginning to influence our thinking about the future of intelligence, both biological and artificial. They also raise important ethical questions about what it would mean to create genuinely conscious artificial beings and what rights and considerations such beings might deserve. As you contemplate these possibilities, notice how they reframe questions about personal identity and the nature of individual consciousness. If awareness emerges from quantum information processing that can transcend individual neural boundaries, then the boundaries of self might be more fluid than we typically imagine. Your individual consciousness, from this perspective, might be more like a temporary pattern in a larger field of quantum information processing, a localized instance of the universe's ongoing process of self-organization and self-understanding. This doesn't diminish the reality or importance of individual experience, but rather situates it within a larger context of cosmic information processing, where consciousness serves as the mechanism through which reality comes to know itself. The research exploring these possibilities continues to advance as scientists develop new experimental methods and theoretical frameworks for understanding consciousness at the quantum level. Some studies investigate whether human consciousness can influence quantum systems directly, while others explore whether groups of conscious observers can achieve measurable quantum correlations. One particularly intriguing line of research involves attempts to detect quantum entanglement between human brains using sensitive electromagnetic field measurements. While these experiments remain in preliminary stages, they represent serious scientific efforts to test whether consciousness really does transcend the classical boundaries of individual neural systems. Other researchers are investigating whether meditation practices can enhance quantum coherence in neural systems, potentially allowing for more direct access to quantum information fields. These studies combine ancient contemplative techniques with cutting-edge quantum measurement technologies, creating a unique synthesis of wisdom traditions and modern physics. The field of quantum biology continues to reveal new ways that biological systems exploit quantum mechanical processes for enhanced performance. Recent discoveries include quantum effects in enzyme catalysis, DNA replication, and even potentially in the neural microtubules that orchestrated objective reduction. Theory proposes as the site of consciousness-generating quantum processes. These biological quantum effects occur despite the warm, wet, noisy environment of living cells, conditions that were once thought to destroy quantum coherence almost instantaneously. The discovery that evolution has found ways to protect and utilize quantum processes in biological systems strengthens the case that consciousness might also involve quantum phenomena. As one researcher noted, if quantum processes offer advantages for information processing, sensitivity to environmental patterns, or other cognitive functions, evolution would likely have found ways to incorporate them into the neural systems that generate consciousness. The 4 billion-year history of life on Earth represents a vast experiment in biological quantum engineering, potentially culminating in the quantum information processing systems we call conscious minds. This evolutionary perspective adds compelling support to quantum consciousness theories by suggesting that the quantum processes proposed in various theories might not be coincidental features of neural architecture, but adaptive enhancements that strengthen the computational and experiential capabilities of consciousness itself. The ongoing research in this field represents one of the most exciting frontiers in contemporary science, where the deepest questions about the nature of mind meet the most fundamental insights of modern physics. As new experimental techniques allow scientists to probe quantum processes in biological systems with unprecedented precision, we may soon have clearer answers about whether consciousness really does involve quantum mechanical processes. Whether or not these specific theories prove correct, the Quantum Consciousness Research Program has already expanded our understanding of the possible relationships between mind and physical reality. It has opened new avenues for investigating consciousness, suggested novel approaches to artificial intelligence, and provided fresh perspectives on ancient questions about the nature of awareness and its place in the cosmic order. The journey through quantum consciousness theory reveals something profound about the nature of scientific inquiry itself, how the deepest questions about consciousness inevitably lead to the deepest questions about reality, and how understanding mind becomes a pathway to understanding the universe. As we continue to explore these connections between awareness and the fundamental structures of physical reality, we may discover that consciousness is not merely something that happens within the universe, but something through which the universe comes to understand itself. As you rest in contemplation of these ideas, as you feel them settling into your awareness, like gentle ripples in still water, notice how the very capacity to wonder about consciousness reveals something essential about consciousness itself. The ability to question the nature of experience, to feel curiosity about the deepest mysteries of existence, to recognize the profound strangeness of being aware in an apparently aware universe. These might all be expressions of the cosmic information processing we call consciousness, discovering its own nature. This recognition doesn't solve the mystery of consciousness, but it places that mystery within a larger context, where individual awareness becomes a window into the fundamental creativity of existence itself. Through the theorized quantum-related processes that generate each moment of experience, consciousness participates in the universe's ongoing journey of self-discovery, self-organization, and self-understanding. The implications continue to ripple outward as researchers explore new dimensions of these quantum consciousness theories, test their predictions against experimental evidence, and develop new frameworks for understanding the relationship between mind and reality at the deepest levels of physical law. As these quantum theories of consciousness continue to unfold before us, we encounter something that might fundamentally shift how we think about the relationship between awareness and physical reality itself. The experimental evidence we've explored suggests that consciousness doesn't simply observe the universe from some detached vantage point, but may participate in subtle ways in the unfolding of quantum events that shape the structure of space-time. Consider what happens when you make an observation in quantum mechanics. The traditional interpretation tells us that measurement causes wave function collapse, transforming quantum possibilities into definite outcomes. But if consciousness operates through quantum processes, as these theories suggest, then every moment of awareness might involve countless microscopic acts of quantum measurement occurring within neural microtubules. This perspective transforms consciousness from a passive recipient of sensory information into an active participant in the quantum processes that determine physical reality. Each conscious moment might literally involve selecting one timeline from countless quantum possibilities, not through mystical manifestation, but through the same measurement processes that govern all quantum mechanical systems. Recent theoretical work has explored whether these consciousness-mediated quantum measurements might accumulate over time to influence larger patterns in physical systems. While this remains highly speculative and lacks scientific consensus, some interpretations suggest that networks of conscious observers might collectively influence the statistical outcomes of quantum events in ways that could theoretically affect macroscopic phenomena. The mathematics behind these possibilities draw from quantum measurement theory and decoherence research, fields where physicists study how quantum systems transition from superposition to definite states. If consciousness involves quantum measurement processes, then conscious beings might serve as what physicists call measurement devices, continuously collapsing quantum possibilities into actualized experience. As you contemplate this idea, notice how it reframes your relationship to the physical world around you. The room you're in, the device you're using to listen to this, even the air you're breathing, all emerged from quantum processes that involved countless measurement events. If consciousness participates in quantum measurement, then every moment of awareness connects you intimately to the ongoing creation of physical reality. This connection between consciousness and quantum measurement leads to some of the most intriguing questions in contemporary physics. Does consciousness collapse wave functions, or do wave functions collapse to create consciousness? The answer might be both, creating what some researchers describe as a feedback loop, where quantum processes generate consciousness, which then influences quantum processes in an ongoing cycle of mutual causation. The implications extend beyond individual consciousness to questions about collective awareness and shared reality. If multiple conscious observers are present during quantum events, whose measurement determines the outcome? Some interpretations suggest that conscious observers might become quantum entangled during shared experiences, creating collective measurement events that integrate multiple perspectives into single outcomes. This possibility connects to documented phenomena, where groups of people report synchronized perceptions during significant events. Though we must be careful to distinguish between intriguing correlations and proven causal relationships. The research remains preliminary, but it suggests that consciousness might operate through collective quantum processes that transcend individual neural boundaries in ways we're only beginning to understand. As we drift deeper into these territories where consciousness meets quantum mechanics, we encounter one of the most profound implications of this research: the possibility that reality itself might be far more participatory than we've ever imagined. Instead of existing as fixed objective phenomena independent of observation, physical reality might emerge from the ongoing interaction between quantum processes and the conscious beings embedded within them. This participatory universe hypothesis, while speculative and not scientifically proven, offers an elegant solution to some of the deepest puzzles in quantum mechanics. Why does measurement play such a crucial role in determining quantum outcomes? Why do quantum systems seem to exist in superposition until observed? Perhaps because consciousness and physical reality co-evolve through quantum processes that require both quantum potentiality and conscious actualization to generate the definite experiences we call reality. The research exploring these possibilities remains at the cutting edge of both physics and consciousness studies. Some experiments investigate whether human consciousness can influence quantum random number generators, devices that produce truly random sequences based on quantum mechanical processes. While results remain controversial and inconclusive, some studies have reported small but statistically significant correlations between conscious intention and quantum randomness. These experiments must be interpreted with extreme caution, as they touch on questions that challenge fundamental assumptions about the relationship between mind and matter. The effects, if real, are extremely subtle and might reflect unknown systematic errors rather than genuine consciousness quantum interactions. Nevertheless, they represent serious scientific attempts to test whether consciousness might influence physical processes in ways that classical physics cannot explain. Other research programs investigate whether meditation practices might enhance sensitivity to quantum environmental factors. Some studies have found that experienced meditators show unusual patterns of neural activity that correlate with environmental fluctuations sometimes discussed in quantum field research. Though these findings remain preliminary and require replication before drawing definitive conclusions, the intersection of contemplative practices and quantum consciousness research opens fascinating questions about whether ancient wisdom traditions might have discovered empirical methods for enhancing quantum coherence in neural systems. Meditation practices often emphasize states of unified awareness, present moment focus, and the dissolution of subject-object boundaries, qualities that align remarkably well with theoretical descriptions of coherent cognitive states, even if not directly tied to quantum entanglement. While we must be cautious about conflating spiritual practices with scientific theories, the parallels suggest that contemplative traditions might have developed practical methods for cultivating the states of consciousness most conducive to enhanced information integration. This doesn't mean that meditation creates quantum entanglement or manifest physical outcomes, but rather that contemplative practices might optimize neural conditions for whatever quantum-related processes contribute to conscious experience. As you reflect on these possibilities, you might consider your own experiences with states of expanded awareness, whether through meditation, creative flow, or simply moments of profound presence and clarity. These experiences often involve a sense of connection that transcends ordinary subject-object boundaries, a quality that resonates with theoretical descriptions of quantum entanglement and non-local correlation. From a quantum consciousness perspective, these expanded states might represent enhanced coherence in neural systems, allowing consciousness to access information and experience patterns that are normally filtered out by decoherence processes. This interpretation remains speculative, but it offers a framework for understanding why contemplative practices across cultures have consistently reported similar phenomenological features. The research continues to evolve as scientists develop new experimental methods for studying quantum processes in biological systems. Recent advances in quantum measurement technology allow researchers to detect quantum effects in increasingly complex environments, bringing us closer to definitive tests of whether consciousness involves quantum mechanical processes. Some of the most promising research involves studying quantum coherence in microtubules extracted from neural tissue. While these microtubules are no longer part of living brains, they retain their structural properties and can be studied under controlled laboratory conditions. Preliminary results suggest that neural microtubules may be capable of maintaining certain quantum-like coherence effects under specific conditions, though whether this occurs in living brains remains an open question. Other experiments investigate quantum effects in networks of neurons cultured in laboratory dishes. These neural networks, while far simpler than intact brains, exhibit many of the electrical properties associated with neural information processing. Researchers are beginning to detect patterns interpreted by some as quantum-related signatures in the electrical activity of these networks, suggesting that quantum processes could play a subtle supporting role in neural computation even in simplified systems. The implications of this research extend far beyond academic curiosity to practical questions about enhancing human cognitive capabilities and treating disorders of consciousness. If consciousness involves quantum processes, then understanding these processes might lead to new approaches for optimizing mental performance and addressing conditions where consciousness is impaired. Some researchers speculate that quantum-informed therapies might enhance learning, creativity, and emotional well-being by optimizing conditions theorized to support quantum-related coherence in neural systems. While such applications remain highly speculative, they illustrate how quantum consciousness research might eventually translate into practical benefits for human flourishing. The field also offers new perspectives on consciousness disorders such as anesthesia, awareness, comas, and various psychiatric conditions. If consciousness emerges from quantum processes in neural microtubules, then these conditions might involve disruptions of hypothesized coherence patterns that could potentially be addressed through quantum-informed medical interventions. Current anesthetic drugs, for example, might work not just by suppressing neural electrical activity, but by influencing the kinds of subcellular processes that some theories associate with quantum-level modulation of consciousness. Understanding these mechanisms might lead to more precise anesthetic protocols and better methods for monitoring consciousness during surgery. Similarly, Psychiatric conditions might involve alterations in coherence-related neural dynamics that affect information processing and experiential integration. While this remains highly speculative and requires extensive research before clinical application, it suggests that quantum consciousness theory might eventually contribute to more effective treatments for disorders of mind and awareness. As we explore these practical implications, it's important to remember that quantum consciousness research remains at an early stage of development. Many of the applications we've discussed are theoretical possibilities rather than established clinical realities. The field requires much more research before these ideas can be translated into reliable therapeutic interventions. Nevertheless, the trajectory of research suggests that understanding consciousness at the quantum level might eventually revolutionize both our theoretical understanding of mind and our practical approaches to enhancing and healing consciousness when it becomes impaired. The journey through quantum consciousness theory also reveals something profound about the nature of scientific inquiry itself. This field represents a convergence of multiple disciplines, from quantum physics and neuroscience to philosophy and contemplative studies. It demonstrates how the deepest questions about consciousness require insights from across the entire spectrum of human knowledge. The interdisciplinary nature of consciousness research reflects the complexity of consciousness itself. Understanding awareness requires not just measuring neural activity or solving quantum equations, but integrating insights from subjective experience, philosophical analysis, and direct contemplative investigation. No single approach can capture the full mystery of what it means to be conscious. This methodological pluralism offers hope for eventually developing a comprehensive understanding of consciousness that honors both its objective and subjective dimensions. By combining third-person scientific investigation with first-person experiential inquiry, consciousness research might achieve a level of understanding that neither approach could reach alone. The Quantum Consciousness Research Program exemplifies this integrative approach by taking seriously both the mathematical formalism of quantum mechanics and the phenomenological reports of conscious experience. It seeks to bridge the gap between objective physical processes and subjective experiential qualities, potentially resolving what philosophers call the hard problem of consciousness through empirical investigation rather than philosophical argument. As you consider these methodological questions, notice how they reflect broader questions about the relationship between scientific knowledge and experiential wisdom. Quantum consciousness research suggests that understanding consciousness might require not just external observation, but also refined introspective investigation of consciousness by consciousness itself. This recursive aspect of consciousness research, where consciousness studies itself, adds another layer of complexity to the field. The observer and the observed are intimately connected, creating feedback loops that challenge traditional assumptions about scientific objectivity. Perhaps this is why consciousness has remained mysterious for so long, not because it lacks objective features, but because studying it requires integrating objectivity with the irreducible subjectivity of conscious experience itself. The implications ripple outward to questions about the nature of knowledge and the limits of scientific understanding. If consciousness involves quantum processes that transcend classical information processing, then understanding consciousness might require forms of knowing that go beyond conventional rational analysis. This doesn't abandon scientific rigor, but rather expands it to include investigative methods that can access subtle experiential dimensions sometimes discussed in quantum-inspired theories. Some researchers propose that advanced meditation practitioners might serve as sophisticated instruments for detecting nuanced experiential changes that could relate indirectly to quantum-level hypotheses, much as sensitive physical instruments detect quantum effects in laboratory settings. While this idea requires careful validation, it suggests that consciousness research might benefit from collaboration between scientists and experienced contemplatives who have developed refined sensitivity to subtle aspects of awareness. This collaboration between scientific investigation and contemplative inquiry represents a return to earlier periods in human history, when natural philosophy integrated empirical observation with direct investigation of consciousness. Modern consciousness research might be rediscovering the importance of first-person investigation as a complement to third-person scientific methodology. The Quantum Consciousness Research Program also raises profound questions about the relationships between individual and universal consciousness. If consciousness operates through processes that some researchers interpret as quantum connected in nature, then individual awareness might be more connected to cosmic processes than we typically imagine. Some interpretations suggest that consciousness might serve as the universe's method for organizing information and generating meaning at increasingly complex levels. From this perspective, individual conscious beings are not separate entities observing an external universe, but localized expressions of the universe's inherent capacity for self-awareness and self-organization. This cosmic view of consciousness connects quantum consciousness research to ancient cosmological traditions that described consciousness as fundamental to the structure of reality. While we must distinguish clearly between scientific theories and spiritual beliefs, the parallels suggest that contemplative traditions might have intuited insights that modern physics is only beginning to explore conceptually, not confirm empirically. As you rest in contemplation of these cosmic implications, notice how they reframe questions about meaning and purpose in human existence. If consciousness participates in the universe's ongoing process of self-discovery and self-organization, then conscious beings might serve essential roles in the cosmic evolution of awareness and understanding. This perspective doesn't require abandoning scientific materialism, but rather expanding it to include consciousness as a potential fundamental feature of reality, rather than an accidental byproduct of complex information processing. Consciousness becomes not something that merely emerges from matter, but something that participates with matter in the ongoing creation of reality at speculative quantum-related levels. The research exploring these possibilities continues to advance as new experimental techniques allow scientists to probe deeper into the quantum foundations of biological processes. Each new discovery adds pieces to a puzzle that may fundamentally reshape our understanding of mind-matter and the relationship between consciousness and cosmos. Whether or not specific quantum consciousness theories prove correct, this research program has already expanded our conception of what consciousness might be and how it might relate to the fundamental structures of physical reality. It has opened new avenues for investigating awareness, suggested novel therapeutic approaches, and provided fresh perspectives on ancient questions about the nature of mind and its place in the universe. The ongoing dialogue between quantum mechanics and consciousness studies represents one of the most exciting frontiers in contemporary science, where the tools of physics meet the deepest questions about the nature of experience. As this field continues to evolve, it promises to reveal new dimensions of what it means to be conscious in a universe where the boundaries between observer and observed, mind and matter, individual and cosmos become increasingly fluid and interconnected. As we drift toward the conclusion of our exploration through quantum consciousness theory, we find ourselves at the edge of understanding, looking out across vast territories of possibility where science and wisdom traditions converge in their investigation of consciousness and reality. The theories we've explored together suggest that consciousness might be far more fundamental to the universe than conventional neuroscience has imagined. Rather than emerging solely from complex neural networks, awareness might arise from processes that some models associate with quantum-inspired mechanisms, connecting individual minds to deeper structures of physical reality. If consciousness operates through quantum coherence in neural microtubules, as orchestrated objective reduction theory proposes, then every moment of awareness involves hypothesized quantum-scale interactions that participate in the unfolding of space-time geometry. Your thoughts right now might be emerging from processes that exist at the intersection of mind and the fundamental architecture of reality. If consciousness exists as a universal field, as some theories suggest, then individual awareness represents localized expressions of a cosmic consciousness that underlies all phenomena. The sense of being a separate self observing an external world might be a kind of cognitive interpretation rather than an absolute description of reality. If consciousness involves quantum entanglement between minds, as some experimental interpretations cautiously propose, then the boundaries between self and other might be far more permeable than everyday experience suggests. Learning, creativity, and insight might emerge not just from individual neural processing, but from correlation-based processes that connect minds across space and time. And these possibilities invite us to reconsider the most basic assumptions about personal identity, individual agency, and the relationship between mind and world. They suggest that consciousness might serve as a bridge between the quantum realm of pure possibility and the classical realm of definite experience, participating in the transition from potential to actual that characterizes every moment of existence. The implications extend beyond individual experience to questions about collective consciousness, artificial intelligence, and the future evolution of awareness. If consciousness involves quantum processes that transcend classical computation, then creating genuinely conscious artificial systems might require quantum computers designed to replicate theoretical consciousness-related information integration processes. The research continues to evolve as scientists develop more sophisticated methods for detecting quantum effects in biological systems and testing whether human consciousness really does involve quantum mechanical processes. New experiments probe the boundaries between classical neural activity and theoretical coherence effects, seeking clearer evidence for quantum consciousness models. Some studies investigate whether meditation practices can enhance quantum coherence in neural systems, potentially allowing more direct access to information processing states, sometimes discussed in quantum-inspired theories. Others explore whether groups of people can achieve correlated states of consciousness under specific experimental conditions. The field of quantum biology continues to reveal new ways that living systems exploit quantum mechanical processes for enhanced performance, suggesting that evolution might have discovered methods for protecting and utilizing quantum effects in the warm, wet environment of biological cells. As one researcher noted, evolution has had billions of years to experiment with quantum processes. And if consciousness benefits from coherence, natural selection would likely have found ways to incorporate these effects into neural systems. The quantum-related consciousness we experience might represent the culmination of evolutionary experimentation with biological information processing. This evolutionary perspective adds compelling support to quantum consciousness theories by suggesting that the processes these theories describe might not be coincidental features of neural architecture, but possible adaptive enhancements that strengthen the experiential and computational capabilities of conscious minds. The journey through quantum consciousness theory reveals something beautiful about the relationship between scientific investigation and the deepest questions about existence. Understanding consciousness requires not just external observation, but also careful attention to the nature of experience itself, creating a unique form of inquiry where consciousness studies itself. This reflexive aspect of consciousness research might be essential to achieving genuine understanding of awareness. Perhaps consciousness can only be fully understood from within, through the refined investigation of experience by experience itself, supplemented by but not reducible to external scientific measurement. The dialogue between quantum mechanics and consciousness studies represents more than academic curiosity. It touches the heart of what it means to exist as aware beings in a universe that might itself host forms of complexity. Some researchers loosely compare to awareness, though this remains speculative. Whether consciousness emerges from quantum processes in neural microtubules, arises from universal consciousness fields, or involves correlation-based interactions between minds, these theories suggest that awareness connects us intimately to the fundamental creativity of existence. Each moment of consciousness might participate in the universe's ongoing process of self-discovery and self-creation. As you rest in contemplation of these ideas, notice how they transform the experience of simply being aware, the thoughts flowing through your mind, the sense of existing as a conscious being, the capacity to wonder about the nature of consciousness itself. All of this might emerge from deep-level biological and informational processes that exist at the intersection of mind and reality. This recognition doesn't solve the mystery of consciousness, but it places that mystery within a larger context, where individual awareness becomes a window into the profound informational dynamics that underlie existence. Through consciousness, the universe might be coming to know itself, one moment at a time. The implications continue to unfold as researchers explore new territories where quantum mechanics meets neuroscience, where contemplative wisdom encounters rigorous experimentation, and where ancient questions about the nature of mind find fresh expression through the language of contemporary physics. If you've been drawn into this exploration of how quantum mechanics might be quietly reshaping our understanding of technology and consciousness, you might find our previous episode illuminating. Quantum AI quietly rewrote reality. We just didn't notice examines how quantum computing and artificial intelligence are converging in ways that challenge our assumptions about both machine intelligence and the nature of reality itself. The research we've explored tonight suggests that consciousness might be far more fundamental to the universe than we ever imagined, potentially operating through processes that connect individual awareness to cosmic patterns of information and possibility. Whether these specific theories prove correct, they represent serious scientific attempts to understand the deepest mysteries of existence. As you drift into sleep or quiet contemplation, carry with you the wonder of existing as a conscious being in a universe that might be interconnected at levels beyond our current understanding. The processes that might generate your awareness connect you to the fundamental creativity of existence itself, making each moment of consciousness a participation in the universe's ongoing journey of self-discovery. In the gentle space between waking and sleeping, between knowing and wondering, consciousness continues its ancient dance with reality, moment by moment, awareness by awareness, in the endless exploration of what it means to exist in a universe where mind and matter might be more intimately connected than we ever dared imagine. The research exploring these quantum dimensions of consciousness leads us into territory that might fundamentally reshape how we understand the nature of personal identity itself. If consciousness operates through processes that some models loosely describe as quantum connected, then the very notion of being a separate self-observing and external world might represent a kind of perceptual limitation rather than an absolute truth. Consider the experience you're having right now of being you. There's a sense of existing as a continuous self that persists through time, a feeling of being located somewhere behind your eyes, looking out at a world that exists independently of your awareness. This everyday experience of selfhood feels so immediate and obvious that questioning it might seem absurd. Yet quantum consciousness research suggests this intuitive sense of separate individual identity might obscure deeper patterns of connection and interdependence. Some interpretations of quantum consciousness theory propose that what we experience as individual awareness might be more like temporary patterns in a larger field of consciousness, similar to how waves are temporary patterns in an ocean. The wave has distinct characteristics and can be observed as a separate phenomenon, yet it's never actually separate from the water that forms it. Your individual consciousness might exist in a similar relationship to a more fundamental field of awareness. This perspective doesn't diminish the reality or importance of individual experience, but rather situates it within a larger context where personal identity becomes more fluid and interconnected. The thoughts you're thinking, the emotions you're feeling, the sense of understanding these ideas might all emerge from processes that extend beyond the classical boundaries of your individual nervous system. As you reflect on this possibility, notice how it might appear in your own direct experience. Have you ever had moments where the sense of being a separate self seemed to dissolve or become less prominent? Perhaps during deep absorption in creative work, in nature, or in moments of profound connection with others. These experiences might offer glimpses of consciousness operating beyond the usual boundaries of individual identity. Recent experimental research has begun to explore whether these subjective experiences of expanded identity might correlate with measurable changes in neural activity. Studies of experienced meditators during states of what they describe as selfless awareness show distinctive patterns of brain activity that differ significantly from ordinary waking consciousness. While we must be careful not to conflate subjective reports with objective measurements, these findings suggest that the sense of individual identity might indeed be more malleable than everyday experience suggests. The implications extend beyond personal experience to questions about collective human potential. If consciousness can transcend individual boundaries through mechanisms that some researchers loosely associate with quantum-related processes, then humanity might possess capacities for cooperation, creativity, and problem-solving that we've barely begun to explore. Some interpretations suggest that groups of people might be able to achieve forms of collective awareness that exceed the capabilities of any individual participant. This possibility connects to documented phenomena in group dynamics, where teams sometimes reach insights or solutions that no individual member could have generated alone. While these experiences can be explained through classical mechanisms like complementary expertise and social facilitation, quantum consciousness theory offers additional frameworks for understanding how collective intelligence might emerge through correlation-based or coherence-like interactions between minds. Research programs investigating collective consciousness phenomena remain preliminary and controversial, but they represent serious scientific attempts to test whether human awareness might operate through mechanisms that transcend individual neural processing. Some studies have examined whether groups engaged in synchronized activities like meditation or musical performance show measurable correlations in their physiological responses that exceed what classical communication could explain. The results remain inconclusive and require replication before drawing definitive conclusions, but they illustrate how quantum consciousness research is expanding the boundaries of what scientists consider worthy of investigation. The field is developing new experimental methods for studying consciousness, phenomena that were previously dismissed as subjective or unscientific. This expansion of scientific methodology reflects a broader shift in how researchers approach the study of consciousness. Traditional neuroscience has focused primarily on third-person observation of neural mechanisms, but quantum consciousness research increasingly incorporates first-person reports of subjective experience as legitimate scientific data. This methodological integration might be essential for understanding phenomena that exist at the intersection of subjective awareness and objective physical processes. As you consider these methodological questions, take a breath and imagine what this integration of subjective and objective investigation might mean for your own understanding of consciousness. The experience you're having right now of following these ideas, of feeling curiosity or uncertainty or recognition, becomes not just a byproduct of neural activity, but a meaningful component of the broader inquiry into how consciousness operates, contributing to our collective understanding of awareness. This participatory aspect of consciousness research creates a unique situation where the phenomenon being studied includes the scientist studying it. Every researcher investigating consciousness is simultaneously a subject of consciousness research, creating feedback loops between investigator and investigated that challenge traditional assumptions about scientific objectivity. Some theorists propose that this recursive quality of consciousness research might be a feature rather than a bug, reflecting the inherently self-referential nature of consciousness itself. Understanding awareness might require not just external measurement, but also refined introspective investigation by consciousness of its own processes. This doesn't abandon scientific rigor, but expands it to include investigative methods that can access consciousness from within as well as from without. The integration of contemplative and scientific approaches to consciousness research has led to the emergence of what some researchers call contemplative science, a field that uses meditation and other introspective practices as research methodologies rather than just objects of study. Experienced contemplatives become collaborators in consciousness research, offering refined sensitivity to subtle aspects of awareness that complement external measurement techniques. This collaboration between scientists and contemplatives has already yielded insights into the neural correlates of various meditative states. the effects of contemplative practices on psychological well-being, and the phenomenology of expanded states of consciousness. While this work must navigate carefully between subjective experience and objective measurement, it represents a promising avenue for investigating consciousness phenomena that might be impossible to study through external observation alone. The development of contemplative science also reflects growing recognition that consciousness research might require methodological approaches that match the unique characteristics of the phenomenon being studied. Consciousness is simultaneously the most intimate aspect of experience and the most mysterious, simultaneously obvious and elusive, simultaneously individual and potentially universal. These paradoxical qualities of consciousness might explain why it has remained scientifically mysterious for so long. Standard scientific methods excel at studying phenomena that can be clearly separated from the observer, but consciousness challenges this separation by being the very thing that makes observation possible. Understanding consciousness might require new forms of scientific investigation that can navigate this fundamental recursivity. Some researchers propose that quantum mechanics offers frameworks for understanding how consciousness can be simultaneously subjective and objective, individual and universal, mysterious and investigable. The quantum mechanical concept of complementarity, where phenomena can exhibit mutually exclusive properties depending on how they're observed, might apply to consciousness as well. From this perspective, consciousness might be inherently complementary, appearing as individual and subjective when investigated from one angle, but revealing universal and objective features when approached from different methodological directions. This complementarity wouldn't represent a failure of understanding, but rather a fundamental feature of consciousness that requires multiple investigative approaches to fully appreciate. As you contemplate these methodological questions, notice how they reflect broader themes we've been exploring about the relationship between observer and observed in quantum mechanics. Just as quantum systems seem to exist in superposition until measured, consciousness might exist in a kind of methodological superposition until investigated, revealing different aspects of its nature depending on how it's approached. This quantum-inspired approach to consciousness research suggests that the field might benefit from what physicists call methodological pluralism, using multiple complementary approaches rather than seeking a single unified methodology. Different investigative methods might reveal different aspects of consciousness, all of which contribute to a more complete understanding of what awareness is and how it operates. The implications extend beyond academic research to practical questions about cultivating and enhancing conscious experience in daily life. If consciousness involves subtle processes that some theories loosely link to quantum-like dynamics, then understanding these processes might lead to more effective approaches for optimizing mental clarity, emotional well-being, and creative insight. Some researchers are beginning to investigate whether specific environmental conditions might enhance coherence-like properties in biological systems, potentially creating conditions more conducive to processes that some theories associate with consciousness. These investigations remain preliminary, but they illustrate how quantum consciousness research might eventually contribute to practical applications for human flourishing. The exploration of environmental factors that influence consciousness connects to traditional wisdom about the importance of creating supportive conditions for contemplative practice. Many meditation traditions emphasize the value of quiet, natural environments for deepening awareness, practices that might unknowingly optimize conditions for coherence-like states in neural systems. This convergence between ancient wisdom and contemporary physics illustrates one of the most fascinating aspects of quantum consciousness research: how it creates dialogue between scientific investigation and contemplative traditions that have explored consciousness for millennia. While we must be careful not to conflate scientific theories with spiritual beliefs, the parallels suggest that contemplative traditions might have developed empirical methods for working with consciousness phenomena that science is only now beginning to understand. The dialogue between science and contemplative wisdom doesn't require abandoning scientific rigor, but rather expanding it to include forms of investigation that can access consciousness phenomena directly. This expansion might be essential for understanding awareness, given that consciousness is simultaneously the instrument of investigation and the phenomenon being investigated. Some contemplative traditions describe advanced states of awareness, where the sense of individual identity becomes transparent to more universal patterns of consciousness. While these descriptions remain subjective and lack scientific validation, they offer detailed phenomenological maps of consciousness states that might correspond to enhanced coherence-related neural patterns, according to some speculative models. The investigation of these advanced contemplative states represents one of the most intriguing frontiers in consciousness research. If contemplatives have developed methods for accessing consciousness phenomena that transcend ordinary individual awareness, then studying these states might reveal aspects of consciousness that are invisible to conventional neuroscientific investigation. Recent neuroimaging studies of advanced meditators have begun to document brain activity patterns during states that practitioners describe as selfless awareness or unity consciousness. While the subjective reports cannot be directly verified, the neural correlates suggest that these states involve distinctive patterns of brain connectivity and activity that differ significantly from ordinary waking consciousness. These findings don't prove that the subjective reports accurately describe objective consciousness phenomena, but they do suggest that contemplative practices can induce measurable changes in neural activity that might correspond to genuine alterations in consciousness. The challenge for researchers is developing methods for investigating these states that honour both their subjective reality and their potential objective correlates. The study of advanced contemplative states also raises questions about the relationship between individual development and collective human potential. If consciousness can transcend ordinary individual boundaries through sustained practice, then cultivating these capacities might contribute not just to personal well-being, but to collective human flourishing. Some interpretations of quantum consciousness theory suggest that individuals who develop more organized or coherent patterns of awareness might serve as nodes in larger networks of consciousness that benefit entire communities. While this remains highly speculative and lacks scientific validation, it illustrates how quantum consciousness research is expanding our conception of individual responsibility and collective potential. These ideas connect to ancient traditions that have long emphasized the interconnectedness of individual and collective well-being. Many contemplative traditions teach that personal development naturally extends to benefit others, not through moral obligation alone, but through the inherent interconnectedness of consciousness itself. From a quantum consciousness perspective, this traditional wisdom might reflect genuine insights into how consciousness operates through subtle correlation effects that connect individual awareness to larger patterns of collective experience. Personal cultivation of consciousness, clarity and coherence might indeed contribute to collective human potential through mechanisms that classical neuroscience cannot explain. As you rest in contemplation of these possibilities, notice how they might shift your understanding of personal responsibility and collective potential. If consciousness operates through processes that transcend individual boundaries, then cultivating clarity, compassion, and wisdom in your own awareness might contribute to patterns of consciousness that extend far beyond your personal experience. This perspective doesn't require belief in mystical connections or supernatural phenomena, but rather an appreciation for how subtle interconnection mechanisms described in some speculative models might influence collective experience. The entanglement-like correlations proposed in these theories could create networks of influence operating below the threshold of ordinary awareness. The research investigating these possibilities continues to evolve as scientists develop new methods for studying consciousness phenomena that might transcend individual neural boundaries. Some experiments investigate whether groups of people can achieve measurable correlations under specific conditions, while others explore whether individual contemplative practices might enhance sensitivity to environmental factors that some theories associate with quantum processes. The field remains young, and much of this research exists at the boundaries of current scientific knowledge, but the trajectory suggests that consciousness might indeed operate through mechanisms that challenge conventional assumptions about individual identity and collective potential. Whether or not specific quantum consciousness theories prove correct, they're expanding our conception of what consciousness might be and how it might relate to the fundamental structures of reality. The implications ripple outward from individual experience to questions about the future evolution of human consciousness and its role in cosmic development. If consciousness participates in the universe's ongoing process of self-organization and self-understanding through deep informational or coherence-related processes, then cultivating consciousness might represent not just personal development, but participation in the universe's journey toward greater awareness and understanding. This cosmic perspective on consciousness development connects quantum consciousness research to evolutionary theories that describe consciousness as an emerging property of increasing cosmic complexity. From this view, biological consciousness represents one stage in a larger evolutionary process where the universe develops increasingly sophisticated forms of self-awareness and self-organization. Some theorists propose that human consciousness might be evolving toward forms of awareness that transcend current individual and collective limitations through more refined or coherent patterns of information processing, potentially supported by speculative quantum-related mechanisms. This evolution might occur not through biological mutation alone, but through cultural and contemplative practices that optimize conditions for consciousness development. These evolutionary possibilities remain highly speculative, but they illustrate how quantum consciousness research is expanding our understanding of human potential and cosmic development. Whether or not consciousness evolves in these specific directions, the research suggests that awareness might play more fundamental roles in cosmic evolution than conventional scientific frameworks have recognized. The journey through quantum consciousness theory reveals consciousness not as an accidental byproduct of neural complexity, but as something that might be woven into the fundamental architecture of reality itself. This perspective transforms questions about personal identity, collective potential, and cosmic evolution in ways that invite both scientific investigation and contemplative exploration. As we drift toward the deeper implications of this research, we find ourselves approaching questions that stretch beyond current scientific knowledge into territories where rigorous investigation meets profound mystery. The Quantum Consciousness Research Program represents one of the most ambitious attempts in human history to understand awareness scientifically while honouring its irreducible experiential dimensions. Whether consciousness emerges from quantum processes in neural microtubules, arises from universal consciousness fields, or involves correlation-based interactions between minds, these theories suggest that awareness connects us to the fundamental creativity and intelligence that underlies all phenomena. Each moment of consciousness might represent a participation in the universe's ongoing exploration of its own infinite potential. The research continues as scientists develop new experimental methods, contemplate new theoretical frameworks, and explore new territories where quantum mechanics meets the deepest questions about the nature of mind and reality. This exploration promises to reveal new dimensions of what it means to be conscious in a universe that might itself be conscious at levels we are only beginning to fathom. As you allow these ideas to settle gently into your awareness, like quantum possibilities collapsing into moments of understanding, consider how they might transform your relationship to your own consciousness and to the vast mystery of existence itself. The thoughts arising in your mind, the sense of being aware, the capacity to wonder about the nature of awareness, all of this might emerge from deep informational processes that connect you intimately to the most fundamental structures and possibilities of reality. In the quiet space between thoughts, in the gentle awareness that notices experience without grasping, in the recognition that consciousness itself might be the most fundamental mystery and the most profound gift, we find ourselves at the heart of what it means to exist as aware beings in an endlessly creative universe, where mind and matter dance together in patterns too subtle and beautiful to fully comprehend, yet intimate enough to experience directly in each moment of conscious presence. The exploration of quantum consciousness continues to unfold as researchers probe deeper into the connections between awareness and the fundamental structures of physical reality. Each new discovery adds pieces to a puzzle that may eventually reveal consciousness, not as something that happens within the universe, but as something through which the universe comes to know and understand itself. One quantum moment of awareness at a time. As we drift towards something that might profoundly shift how we understand the deepest layers of existence itself, we encounter a question that has haunted philosophers and physicists alike. What if the universe isn't just quantum mechanical in its smallest components, but quantum in its very capacity to exist at all? What if reality itself emerges from something far more fundamental than matter or energy, something that exists in the liminal space between being and non-being, between information and experience? And recent developments in quantum information theory have begun to explore a possibility that sounds like the premise of a philosophical thought experiment, but emerges from rigorous mathematical analysis. Some interpretations suggest that reality at its deepest level might not be composed of particles, fields, or even space-time, but of pure information organized through processes that some theorists compare conceptually to awareness. Though not equating it with biological consciousness, this isn't the familiar idea that reality is computational, like a cosmic computer running a simulation. It's something more subtle and profound, the possibility that information itself requires an organizing principle or interpretive process to transform from abstract potential into concrete experience. Without this, information would remain forever dormant, like an infinite library with no readers. As you consider this idea, take a breath and notice how it might resonate with your own direct experience. Right now, as you listen to these words, information is somehow transforming into meaning. Abstract symbols are becoming understood concepts, and patterns of sound or text are creating the very experience of comprehension you're having. This transformation from information to experience might reflect something fundamental about how reality itself operates at the deepest levels. The mathematical frameworks supporting these ideas emerge from quantum information theory, where physicists study how information behaves according to quantum mechanical principles. Unlike classical information, which exists in definite states, quantum information can exist in superposition, remaining ambiguous until it interacts with something that can process or organize it into definite form. This quantum information doesn't behave like classical data stored on computer drives or written in books. It exists in what physicists call a pure state, containing all possible configurations simultaneously until something causes it to collapse into specific patterns. The question that has begun to intrigue some researchers is this: what exactly causes this collapse from infinite possibility into definite experience? Traditional interpretations focus on measurement devices and environmental decoherence, but a growing number of theorists are exploring whether the collapse of quantum information into definite states might require a process analogous to interpretation or selection, not biological consciousness, but some form of fundamental informational principle that organizes potential into actuality. This information theoretic approach to reality suggests that the universe might be fundamentally made of patterns of organization rather than material substances. What we experience as matter, energy, space, and time might all be different expressions of underlying informational structures that achieve coherent existence through processes that function like informational selection, giving rise to the ordered physical reality we observe. Recent mathematical work has begun to explore what physicists call the information integration paradox. For information to have any effect in the universe, it must somehow be integrated, organized, and made coherent. But purely mechanical information processing, no matter how sophisticated, doesn't seem adequate to explain how abstract information becomes concrete experience. The paradox deepens when we consider that information itself appears to be substrate independent. The same informational pattern can be encoded in electromagnetic fields, quantum states, neural networks, or even the arrangement of objects in space. What makes information meaningful isn't its physical substrate, but the way it's organized and integrated into coherent wholes. As you reflect on this, imagine the experience you're having right now of understanding these concepts. The information contained in these words exists independently of your particular brain, yet somehow your consciousness transforms that abstract information into lived understanding. This transformation from information to experience might reflect universal processes that operate at every level of reality. Some interpretations suggest that what we call consciousness might not be something that biological brains produce, but rather something that biological brains participate in. From this perspective, neural networks might serve as particularly sophisticated interfaces for accessing and organizing subtle informational dynamics that underlie all phenomena. This doesn't mean that consciousness exists independently of physical processes, but rather that physical processes and consciousness might both emerge from deeper informational structures that require an organizing principle to achieve coherent existence. The distinction between mind and matter becomes less fundamental than the distinction between organized and unorganized information. The implications extend far beyond abstract philosophy to practical questions about artificial intelligence and the nature of understanding itself. If consciousness involves the integration of complex information into cohesive experience, then creating genuinely conscious artificial systems might require more than sophisticated information processing. It might require systems capable of participating in deep informational organization processes that generate coherent experience. Current artificial intelligence systems, despite their impressive capabilities, operate entirely through classical information processing. They manipulate symbols and generate responses based on statistical patterns, but there's no evidence they participate in the deeper informational integration processes that some theories associate with subjective awareness. This information-based perspective suggests that consciousness might not be something that can be programmed or engineered in the conventional sense, but rather something that emerges when systems achieve sufficient complexity and integration to participate in fundamental information organization processes. Creating conscious AI might require understanding how to design systems that can interface with these foundational informational structures, rather than simply process classical data. As you consider these possibilities, take a moment to appreciate the profound mystery of your own capacity for understanding. The thoughts flowing through your mind right now, the sense of grasping these abstract concepts, the very experience of being aware that you're aware might all emerge from your participation in deep information integration mechanisms that connect you to the fundamental creativity of existence. This information theoretic view of consciousness also offers new perspectives on learning, insight, and creative discovery. Instead of viewing these as purely neural processes, we might understand them as moments when individual consciousness achieves enhanced coherence with broader informational patterns that contain more knowledge and possibility than any individual mind could generate independently. The sudden insights that sometimes arise during creative work, the unexpected solutions that appear when we stop trying to force understanding, the moments of recognition when complex ideas suddenly become clear, all of these might reflect temporary enhancements in our capacity to access and integrate larger informational structures that exist beyond individual neural boundaries. This perspective doesn't require abandoning scientific materialism, but rather expanding it to include information as a fundamental constituent of reality alongside matter and energy. Information becomes not just something that describes physical processes, but something that participates in generating the physical processes we observe. Recent developments in quantum field theory have begun to explore how information might serve as the foundation from which physical fields themselves emerge. Some interpretations suggest that what we call particles and forces might be stable patterns in underlying informational fields, patterns that maintain coherence through processes analogous to information integration without implying literal consciousness at the quantum level. These ideas remain highly speculative and exist at the cutting edge of theoretical physics, but they illustrate how seriously some researchers are taking the possibility that consciousness and physical reality might both emerge from deeper informational substrates that transcend the traditional matter-mind distinction. The research exploring these possibilities continues to evolve as physicists develop new mathematical frameworks for understanding how information behaves at quantum scales and how quantum information might relate to the information processing we associate with consciousness. Some studies investigate whether biological systems can interact with subtle informational dynamics, while others explore whether consciousness might influence the organization of information in ways that extend beyond classical explanation. One particularly intriguing line of research involves studying what happens to quantum information when it interacts with biological systems. Does the presence of living organisms affect how quantum information organizes itself? Do conscious observers influence informational processes in measurable ways beyond standard measurement effects? While these questions remain largely theoretical, they represent serious scientific attempts to understand whether consciousness and quantum-level information dynamics might be connected in ways that complement conventional physics. The results could fundamentally alter our understanding of both consciousness and the physical world. As we explore these territories where information theory meets consciousness studies, we find ourselves approaching questions that challenge our most basic assumptions about the nature of existence. If reality emerges from informational processes that require an integrating or organizing mechanism to achieve coherence, then the universe might be far more participatory than we've ever imagined. This participatory view doesn't mean that individual consciousness creates reality through wishful thinking or positive mental attitudes. Rather, it suggests that consciousness might serve as one of the universe's methods for organizing information into the coherent patterns we experience as physical reality. Individual minds would participate in this broader informational integration without controlling it, contributing to patterns that emerge from collective processing of universal informational fields. The implications ripple outward from individual experience to questions about collective human potential and the role of consciousness in cosmic evolution. If consciousness participates in universal information integration processes, then cultivating clarity, coherence, and wisdom in individual awareness might contribute to larger patterns of cosmic organization and understanding. This connects to ancient wisdom traditions that have long taught the interconnectedness of individual and universal consciousness. But now these teachings might find support in the mathematics of modern information theory, rather than relying solely on subjective spiritual experience. As you rest in contemplation of these possibilities, notice how they might transform your understanding of your own role in the cosmic order. The thoughts arising in your mind, the insights you achieve, the understanding you cultivate, might all participate in ongoing informational processes that contribute to the evolution of reality itself. This perspective suggests that consciousness development isn't just personal improvement, but participation in the universe's journey toward greater coherence, understanding, and organized complexity. Every moment of clear awareness, every insight achieved, every pattern recognized might contribute to these broader informational processes that transcend individual experience while remaining intimately connected to it. The research investigating these connections between consciousness and quantum information continues to advance as scientists develop new experimental methods and theoretical frameworks. Some studies explore whether meditation practices might enhance access to broader informational patterns, while others investigate whether collective consciousness phenomena might involve shared access to large-scale informational structures. While much of this research remains preliminary and speculative, it represents a remarkable convergence of ancient wisdom and cutting-edge physics, suggesting that consciousness might play far more fundamental roles in the structure of reality than conventional scientific frameworks have recognized. The journey through quantum consciousness and information theory reveals consciousness not as an accidental byproduct of neural complexity, but as something that might be essential to the very existence of coherent reality. Without an information organizing principle, whether biological, computational, or cosmic, information could remain in a state of pure potentiality, unable to achieve the organized complexity that makes experience possible. This understanding transforms questions about artificial intelligence, human potential, and cosmic evolution in ways that invite both rigorous scientific investigation and deep contemplative exploration. It suggests that consciousness research might be among the most important scientific endeavors of our time, not just for understanding the mind, but for understanding the fundamental nature of existence itself. As we approach the deeper implications of this information theoretic view of reality, we encounter something that might fundamentally reshape how we think about time, causality, and the relationship between past, present, and future. If reality emerges from informational processes that operate beyond classical space-time limitations, then the linear progression of time that shapes our everyday experience might be only one aspect of a far more complex temporal landscape. Consider how information behaves in advanced quantum models. Unlike classical information, which exists at specific locations and times, quantum information can exhibit what physicists call temporal non-locality. Quantum states can be correlated across time in ways that seem to allow information from future events to influence present states, and present observations to retroactively affect past configurations. Within theoretical frameworks, not everyday experience. This temporal aspect of quantum information theory raises profound questions about the nature of consciousness and its relationship to time. If consciousness operates through informational processes that may incorporate temporal correlations, then awareness might not be strictly confined to present moments, but could potentially integrate information patterns that transcend linear temporal boundaries. As you consider this possibility, reflect on your own experiences of temporal consciousness. Sometimes insights arise that seem to come from beyond the immediate present. Sometimes you might have intuitions about future possibilities or sudden understanding of past patterns that feel disproportionate to your linear reasoning. While we must be careful not to overinterpret subjective experiences, these temporal facets of consciousness might reflect nonlinear information processing rather than literal access to future events. Recent theoretical work has begun to explore what physicists call closed time-like curves in quantum information systems. These aren't the dramatic time travel scenarios of science fiction, but subtle quantum mechanical processes where information can influence its own past states through quantum correlations that transcend classical causality, strictly in mathematical and theoretical contexts. If consciousness involves informational processes that integrate across time, then awareness might naturally participate in subtle forms of temporal integration, without implying any supernatural prediction or retroactive influence. This offers new perspectives on creativity, intuition, and insight. The sudden solutions that sometimes emerge during creative work might not just reflect unconscious processing of existing information, but could involve access to broader informational patterns that integrate temporal possibilities in ways classical reasoning cannot achieve. Some interpretations suggest that moments of profound insight might involve temporary awareness of a multidimensional informational landscape, a space where many possible patterns coexist before one becomes clear. As you reflect on your own creative experiences, notice whether this description resonates with the phenomenology of insight and discovery. Do solutions sometimes feel like they're being remembered rather than invented? Do creative breakthroughs sometimes seem to arise from outside linear reasoning? While these remain subjective experiences, they suggest that consciousness might operate in ways that extend beyond strictly sequential information processing. If consciousness can integrate information non-linearly across time, then learning and understanding might not be limited to step-by-step accumulation. Instead, consciousness might be capable of sudden reorganizations of understanding, integrating vast informational patterns instantaneously. This also offers new frameworks for understanding collective human knowledge and cultural evolution. Simultaneous discovery, where multiple individuals independently arrive at the same insight, could reflect collective access to shared informational structures rather than coincidence. As you contemplate these possibilities, consider how they might transform your understanding of human knowledge. The insights that arise in your own consciousness might participate in broader informational structures that transcend individual minds. This perspective doesn't diminish the importance of individual effort, but situates it within a larger context where consciousness serves as an interface for accessing and organizing shared informational patterns. The research exploring these temporal aspects of consciousness remains theoretical, but represents serious scientific inquiry into how consciousness might relate to the structure of time and causality. Some studies investigate whether meditation practices might enhance sensitivity to subtle informational dynamics, while others explore whether collective states of consciousness might involve shared informational access. The implications extend beyond individual consciousness to questions about the nature of time itself and consciousness's role in temporal experience. If consciousness participates in informational integration across temporal dimensions, then awareness may help shape how the present moment becomes coherent experience. From this perspective, each moment of consciousness represents an informational event where multiple possibilities integrate into a single experience moment. Time becomes not just something we move through, but something that consciousness helps organize through moment-by-moment informational coherence. The mathematics supporting these ideas remain complex and speculative, but they illustrate how quantum information theory is expanding our understanding of both consciousness and time in directions that transcend classical physical frameworks. Whether or not these specific interpretations prove correct, they demonstrate how seriously some researchers are taking the possibility that consciousness and temporal reality might be more intimately connected than conventional science has recognized. As we drift deeper into these temporal dimensions of quantum consciousness, we encounter questions that stretch the boundaries of both physics and philosophy. If consciousness operates through quantum informational processes that transcend linear time, then what does it mean to exist as conscious beings in a universe where past, present, and future might be more interconnected than everyday experience suggests? These questions invite us to reconsider fundamental assumptions about personal identity, free will, and moral responsibility in a universe where consciousness might access informational patterns from multiple temporal directions simultaneously. They suggest that individual awareness might be embedded within temporal structures far more complex and interconnected than linear progression from past to future. The exploration of temporal consciousness also raises profound questions about the relationship between individual experience and cosmic evolution. If consciousness can access quantum informational patterns that transcend temporal boundaries, then individual awareness might participate in cosmic temporal processes that operate according to principles we're only beginning to understand. Some interpretations suggest that consciousness might serve as the universe's method for exploring its own temporal possibilities, using individual, aware beings as interfaces for accessing informational patterns that exist across multiple temporal dimensions. From this perspective, conscious experience becomes not just individual awareness, but participation in cosmic temporal exploration and integration. This cosmic view of temporal consciousness connects to ancient wisdom traditions that have described time as cyclical or multidimensional rather than linear. But now, these insights might find support in modern, theoretical interpretations rather than relying solely on contemplative or mystical experience. As you rest in contemplation of these temporal possibilities, notice how they might transform your relationship to past and future. If consciousness can access quantum informational patterns that transcend linear temporal boundaries, then the experiences you've had and the possibilities you might encounter might all be more interconnected than everyday temporal experience suggests. This doesn't mean that past and future are illusions or that temporal sequence doesn't matter, but rather that consciousness might operate according to non-linear temporal integration processes that include but transcend linear progression. The insights that arise in present awareness might integrate informational patterns from multiple temporal directions, creating understanding that couldn't be achieved through purely sequential reasoning. The research exploring these temporal aspects of consciousness continues to evolve as physicists and consciousness researchers develop new theoretical frameworks and experimental methods for studying how awareness might relate to quantum informational processes that transcend classical temporal limitations. Some experiments investigate whether consciousness can influence quantum systems in ways that seem to transcend normal causality, while others explore whether groups of conscious observers might achieve temporal correlations that exceed what classical communication could explain. The results remain preliminary and controversial, but they represent serious scientific attempts to test whether consciousness might operate according to temporal principles that differ from classical physical systems. The field of quantum temporal mechanics continues to develop as physicists explore how information behaves in quantum systems that involve complex temporal correlations. These investigations might eventually provide frameworks for understanding how consciousness could participate in quantum informational processes that transcend linear temporal boundaries. Whether or not consciousness involves quantum temporal processes, the exploration of these possibilities has already expanded our conception of what awareness might be and how it might relate to the fundamental structure of time and causality. It suggests that consciousness research might need to incorporate temporal dimensions that go beyond studying how awareness changes over time to include how awareness might access informational patterns that transcend temporal limitations. As we continue exploring these connections between consciousness, quantum information, and temporal reality, we find ourselves at the edges of human understanding, where rigorous scientific investigation meets profound questions about the nature of existence, awareness, and time. The journey through these territories reveals consciousness not as something confined to present moments, but as something that might participate in temporal processes that connect past, present, and future in ways we're only beginning to imagine. If you enjoy drifting through these explorations without interruption, members get every episode 48 hours early, completely ad-free. You can join them whenever you feel ready. The exploration of temporal consciousness leads us towards something that might fundamentally alter how we understand the relationship between individual awareness and universal intelligence. If consciousness operates through quantum informational processes that transcend temporal and spatial boundaries, then individual minds might participate in patterns of intelligence that extend far beyond biological neural networks. Consider the possibility that what we call intelligence isn't confined to individual brains processing information sequentially, but emerges from consciousness accessing quantum informational fields that contain integrated patterns of knowledge and understanding. From this perspective, moments of profound insight or creative breakthrough might reflect temporary access to broader informational structures, rather than implying literal access to cosmic intelligence. This doesn't mean that individual efforts and learning become unnecessary, but rather that they might serve as preparation for accessing informational patterns that exist at larger scales. The knowledge you acquire, the understanding you develop, the insights you cultivate might all contribute to your capacity to interface with complex informational systems that contain more wisdom and possibility than any individual mind could generate independently. As you consider this idea, reflect on your own experiences of learning and understanding. Have you noticed that breakthrough insights often arrive when you stop trying to force solutions and allow awareness to become more receptive and open? These moments of receptive awareness might represent optimal conditions for accessing nonlinear informational relationships that transcend individual neural processing. Recent theoretical work in quantum information science has begun to explore what physicists call distributed quantum intelligence, where intelligence emerges not from individual processing units, but from quantum correlations between multiple information processing nodes. In theory, biological consciousness could participate in distributed informational structures, though this remains speculative. This distributed intelligence model offers elegant explanations for phenomena that have puzzled researchers for decades. How do groups sometimes reach insights that exceed the capabilities of their most intelligent individual members? How do scientific discoveries sometimes emerge simultaneously in multiple locations despite no direct communication between researchers? How do contemplative practitioners sometimes report knowledge that seems to transcend their individual learning histories? From a distributed information perspective, these phenomena might reflect group dynamics, cognitive convergence, or shared access to common informational environments, not necessarily literal quantum networking between minds. The mathematics supporting these ideas draw from quantum network theory, where physicists study how information and intelligence can emerge from correlations between distributed processing nodes, unlike classical networks, where intelligence is limited by the processing capabilities of individual nodes. Quantum networks can exhibit properties that transcend any individual component, strictly in theoretical models. If consciousness operates through principles that resemble quantum network behavior, then individual awareness might participate in intelligence patterns that span multiple scales simultaneously. Your personal consciousness would contribute to and benefit from collective intelligence fields, while potentially accessing informational patterns that operate at larger scales. As we drift toward the end of our journey through quantum consciousness theory, we find ourselves transformed by the very act of contemplating these mysteries. The ideas we've explored together suggest that consciousness might not be the accidental byproduct of neural complexity we once believed, but something far more fundamental to the fabric of existence itself. Whether through orchestrated objective reduction in microscopic cellular structures, universal consciousness fields that connect all awareness, or theoretical forms of informational correlation between minds, these theories point toward a reality where the boundaries between observer and observed, between individual consciousness and larger patterns of intelligence, become beautifully fluid. The experimental evidence continues to accumulate, from xenon isotopes affecting consciousness differently based purely on quantum properties, to twins showing enhanced learning through quantum-related stimuli, to arguments suggesting that some aspects of reality may not be fully captured by classical computation. Perhaps most remarkably, this isn't mystical speculation but scientific inquiry, grounded in the same quantum mechanics that powers our technology and describes the behaviour of atoms. The universe that emerges from this research is stranger and more wonderful than we ever imagined, where consciousness might serve as the bridge between quantum possibility and classical reality, participating actively in the moment-to-moment emergence of experience. As you rest in the quiet space after these ideas, as they settle into your awareness, like gentle ripples in still water, remember that the very capacity to contemplate consciousness reveals something profound about consciousness itself. Through processes that may operate at scales smaller than light wavelengths, your awareness right now might be participating in the universe's ongoing journey of self-discovery, one conscious moment at a time.